Hello everyone, I am Pankaj Kumar Swarnakar, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University Bhilai. Welcome you all again to the course Essential of Surveying, Application and Techniques. In this lecture, we will focus on simplified case studies of surveying operations. We are going to discuss case studies that illustrate the practical application of surveying theories in real world scenarios. Surveying is not just about understanding the concept, it is about effectively applying this knowledge in the field. One of the critical tasks you will encounter in the field is calculation of earthwork, which involves determining the volumes of soil that need to be excavated or filled. This process relies heavily on taking precise level measurement at various points using surveying measurements like dumpy level and auto level. Through the case studies, we will explore how these theoretical principles are put into practice to achieve accurate and efficient result in our earthwork calculations. Now, we will try to understand one important terminology, which is spot level. What is a spot level? Spot level is measurement of the elevation or height of a particular point on the ground relative to a reference datum. Usually, reference datum is mean sea level. As we have also discussed earlier, spot level represent the exact elevation of that point and is often used in surveying and construction to determine the topography of a site. It is determined with reference to benchmark with the help of leveling instrument like dumpy level and auto level. For better understanding, I will give a simple example. If the point A and B have a spot level 100 meters and 120 meters respectively, so what interpretation can be drawn? It denotes that the point B is situated at 20 meter more height than point A. I think you have understood spot level. So, now we can start our discussion on case study, where we need to calculate the volume of earthwork on a plot of a land in which it is required to achieve a specified design level, which involves either cutting or filling of soil to the ground surface. I think you are feeling uncomfortable with some of the terminologies like design level, cutting and filling. So, let us discuss these terminology one by one. What is design level? Design level is the target elevation or height that we plan to reach after performing earthwork operation like cutting and filling. What is cutting? Cutting means removing the soil and filling means adding the soil. You can get better understanding, I think, with this figure. Here you can see point A is below the design level or desired level where we want to reach. So, if we want to reach design level from point A, some filling of the soil will be required. And similarly, you can see point B. Point B is above the design level. So, we are supposed to do the cutting operation to reach up to design level for point B. Now, how can we proceed for measuring the earthwork? So, to accurately calculate the earthwork, the entire area must be divided into a grid system. At each corner of these grids, we will determine existing ground level using surveying instrument like auto level, dumpy level. The goal is to compare this measured level with the desired level of the ground. Means we want the plot to be at a particular desired level, but currently there are undulation in the plot. By applying arithmetic averaging techniques, which we are going to discuss later in this lecture, we can calculate volume of earthwork required to either cut or fill the ground to reach the desired level. Now we can see this example problem. What is the objective? Objective is calculate the volume of earthwork required based on spot level recorded at each grid corner point of a plot with total dimension 100 meter by 100 meter. The design requires plot level to be at a constant elevation of 150 meters. Means we want after the earthwork the level of the plot should come out to be 150 meters. The spot levels are recorded at corners of each grid points. Here we are supposed to divide the plot into number of grids. Then spot levels are recorded at the corner of grid point. If we take grid of size 50 meter by 50 meter and we know the total plot dimension as 100 meter by 100 meter, so we can understand there will be 4 number of grids which will occupy the area. Grids are numbered along x direction as A, B and C. Also numbering along y direction is done as 1, 2, 3. So the numbering of the corners of this grid point can be done as shown in figure. So numbering can be done as 1A, 2A, 3A, 1B, 2B, 3B, 1C, 2C, 3C. Also levels of various corners of grids are given. So in this table you can see the spot level of the grid corner point. So you can see the elevation of A1 is 148.5 meter, elevation of A2 is 149 meter, elevation of A3 is 149.5 meter. Elevation of B1 is 149 meter, elevation of B2 is 149.5 meter, elevation of B3 is 150 meters, elevation of C1 is 150.5 meter, elevation of C2 is 151 meter and elevation of C3 is 151.5 meter. Now what is our goal? Our goal is to bring the plot to a uniform level of 150 meter elevation. Now we will try to solve this problem step by step. So here we have spot levels for various grid point. What do you understand if the level of grid point is more than the desired level, or what do you understand if the level of grid point is less than the desired level? I think you can better understand this with the figure shown. If level of a point is less than the desired level of a ground, example point A shown in figure, then to reach the desired level filling will be required. When level of a point is above the desired level of the ground, example point B, then cutting is required. So we can write depth of cutting or filling as average spot level minus desired level. If it comes out positive, means spot level is higher than the desired level, then cutting is required. If it comes out negative, means spot level is lower than desired level, then filling is required. Now we will calculate earthwork for each grid, for which we are going to follow the following steps. The first step is determination of average elevation of grid points. So here each grid is having 4 grid corners and we are having spot level of these 4 grid corners. So how can we get the average? For the averaging, we can sum those 4 elevation and divide it by 4. Second step is determine depth of cut or depth of fill. For each grid cell, calculate the average elevation of 4 corner, then subtract the required level to determine the depth of cutting or depth of filling. So we can write depth of cutting or filling as average elevation minus required level or designed level. Third step is calculation of volume of earthwork for each grade. It can be calculated by this formula. Volume is equal to area into average depth. Area is area of the grid, average depth is nothing but depth of cut or depth of fill. We can calculate volume as area into average depth. Area is nothing but area of grid, average depth is nothing but depth of cutting or depth of filling. So, let us do the calculation for grid number 1. Grid number 1 means grid formed by 1A, 2A, 1B, 2B. As shown in figure, spot level of grid corner points are, spot level of 1A is 148.5 meter, spot level of 2A is 149 meter, spot level of 1B is 149 meter, spot level of 2B is 149.5 meters. So, we are having spot level of all 4 corners of grid 1. So, what is the first step? The first step is determination of average elevation of grid. So, here we can calculate average elevation as 148.5 plus 149 plus 149 plus 149.5. This summation will be divided by 4 to get the average. Here the average elevation comes out to be 149 meter. Now, we will go to the second step. What is the second step? Determination of depth of cutting or depth of filling. The formula is average spot level minus desired level. Average spot level is 149 meter, desired level is 150 meter. So, when we do the calculation, we will get minus 1 meter. So, minus denote filling is required. Now, the third step is volume of earthwork for each grid. So, the formula we know, volume is equal to area into average depth. Area of grid is 50 meter cross 50 meter means 2500 square meter, and average depth of filling is 1 meter, which is written as minus 1 meter. Minus denote filling. So, volume we can calculate as 2500 into minus 1. So, it will come out to be minus 2500 cubic meter, minus again denotes filling quantity. Now, for grid 2. Grid 2 means 1B, 2B, 1C, 2C. You can see in this figure. Spot level are given as for 1B 149 meter, 2B 149.5 meter, 1C 150.5 meter, 2C 151 meter. So, first step will be determination of average elevation at grid point. If we calculate using the values, we will get it as 150 meter. Now, the next step will be determination of depth of cutting or depth of filling. Here you will observe our desired level is 150 meter and average elevation of grid points is also 150 meter. So, it is kind of balance section. So, the depth of cutting or depth of filling will come out as 0 meter. So, since depth of cutting or filling is 0 meter, then if we go for the volume calculation, which can be done as area into average depth, then we can calculate volume as area into average depth. Average depth is depth of cutting or filling. In this case, it is 0. So, volume will come out as 0 cubic meter. Now, the calculation for grid 3. Grid 3 means grid formed by 2A, 3A, 2B, 3B as shown in figure. Spot levels are given as for 2A 149 meter, 3A 149.5 meter, 2B 149.5 meter, 3B 150 meters. So, what is the first step? Again average elevation of grid point. So, if we calculate average elevation for grid 3, we will get 149.5 meter. We have to just substitute the values. Now, the next thing we are supposed to calculate is determination of depth of cutting or depth of filling. We know the formula, depth of cut or fill is average spot level minus desired level. Here average spot level is 149.5 meter and desired level is 150 meter. So, we will get depth of fill as minus 0.5 meter. Again minus denotes filling. Volume of earthwork we can calculate as area into average depth. Area of the grid is 50 meter by 50 meter means 2500 square meter. Average depth is minus 0.5 meter means filling is required of 0.5 meter height. So, volume will come out to be 1250 cubic meter filling volume. Minus denotes filling volume. Now, if we do the calculation for grid 4 means grid formed by 2B, 3B, 2C and 3C. So, spot level are given as for 2B it is 149.5 meter, for 3B 150 meter, for 2C 151 meter, for 3C 151.5 meter. Now, the first step is average elevation of points. It comes out to be 150.5 meter. Next is determination of depth of cut or fill. Here it comes out as 0.5 meter cutting. Okay. So, with this we can calculate volume of earthwork as area into average depth. Area we know 2500 square meter, average depth is 0.5 meter cutting. So, if we calculate the volume, it will come out as 1250 cubic meter of cutting. Now, if we summarize the earthwork volume by tabulating the result for each grid cell, we can summarize like this. For grid cell number 1, 1A, 2A, 1B, 2B, average depth of cutting or filling is minus 1 means 1 meter filling. Volume is minus 2500 cubic meter means 2500 cubic meter filling is required. For grid number 2, average depth of cut or fill is 0. So, volume of earthwork required will also be 0. For grid number 3, average depth of cut or fill is minus 0.5 and the volume required is minus 1250 cubic meter. Again minus denotes fill quantity. Next grid is grid number 4, average depth is 0.5 meter plus means cutting, average volume is 1250 meters in cutting. So, we can calculate total cutting volume as 1250 cubic meter, total filling volume as minus 2500 minus 1250. If we will do the calculation, we will get minus 3750 cubic meter. So, net earthwork calculation will be total cut minus total fill. So, it will be 1250 minus 3750 means minus 2500 meter cube, or we can say 2500 meter cube filling is the net earthwork. I hope you understood the case study 1. Now, we move forward for the next case study. So, in case study 2, what details are given? Please go through it. Assume we want to calculate earthwork for road construction for a stretch of 100 meter. The road is having width as 10 meter. So, road dimensions are given 100 meter long by 10 meter wide. Spot levels. Spot levels are measured at regular interval to determine the existing ground profile. Design level for the road construction is given as 1 meter. Now, what is our objective? Our objective is to calculate the volume of cutting and filling required for road construction based on spot level at various sections. So, spot level data is with us. Spot level are taken at 10-meter interval along the length of the road. Here an example of data set is given. Spot level given at any station like 0-meter station, 10-meter station, 20-meter station, it is the average spot level at that section. Okay, means I am talking about cross section. In that particular cross section, the given spot level is average spot level, means it is calculated at multiple points and then averaging is done. After that we got this spot level, which is average spot level. We can see at a station 0 meter, average spot level is 0.4 meter. At a station 10 meter, average spot level is 0.6 meter. At a station 20 meter, average spot level is 0.9 meter. At a station 30 meter, average spot level is 1.1 meter. At a station 40 meter, average spot level is 1.3 meter, and similarly spot level at other stations are given. These stations are nothing but the length according to the at which length spot levels are taken in the longitudinal direction, which you can visualize better with this particular figure. So, what we are supposed to do? We are supposed to calculate cross sectional area for cutting and filling at various sections. Determining cross sectional area for each station indicates whether this station will require cutting or filling. So, cross sectional area calculation can be done as cross sectional area will be equal to width of the road into height of cutting or filling, or we can write cross sectional area as width of the road into in the bracket average spot level minus design level. So, if we go for station 0, spot level given is 0.4 meter. We know design level of the road is 1 meter. So, cross sectional area can be calculated as width of the road into height of the cutting or filling, or we have gone through this formula, area is equal to width of the road into average spot level minus design level. Here width of the road is 10 meter, average spot level is 0.4 meter, design level is 1 meter. So, area will come out to be minus 6 square meter. Again minus denotes filling. At station 10 meter, spot level given is 0.6 meter, design level is 1 meter. So, cross sectional area if you will calculate using the similar formula, it will come out to be minus 4 square meter. Again minus denotes filling. At station 20 meter, spot level given is 0.9 meter, design level is 1 meter. So, cross sectional area will be 10 meter into in the bracket 0.9 minus 1. So, it will be minus 1 square meter, minus means filling. At station 30 meter, spot level given is 1.1 meter, design level is 1 meter. So, again cross sectional area can be calculated as 10 meter into in the bracket 1.1 meter minus 1 meter, which will come out to be 1 square meter. At station 40, spot level given is 1.3 meter, design level is 1 meter. So, here the cross sectional area will be 10 meter into in the bracket 1.3 meter minus 1 meter, which will come out as 3 square meter. Again it is positive, means it is in cutting. At station 50, spot level given as 1 meter, design level given as 1 meter. Here we can see spot level is a 1 meter and design level is also 1 meter. So, cross sectional area will become 0. So, no depth of cutting or filling will be available. At station 60, spot level given is 0.8 meter, design level given is 1 meter. So, cross sectional area will be 10 meter into in the bracket 0.8 meter minus 1 meter. So, it will come out as minus 2 square meter. Again minus denotes filling, means Here 2 square meter is the filling quantity. In area terms, volume we are going to calculate later. At station 70 meter, spot level given is 0.7 meter, design level is 1 meter. So, if we calculate cross sectional area, it will come as 10 meter into, in the bracket, 0.7 meter minus 1 meter. So, it will come out as minus 3 square meter. Minus means filling. At station 80, spot level given is 0.9 meter, design level is 1 meter. So, we can calculate cross sectional area as 10 meter into, in the bracket, 0.9 meter minus 1 meter. It will come out as minus 1 square meter. Again, minus denotes the filling quantity. At station 90 meter, spot level given is 1.2 meter, design level is 1 meter. Similarly, we can calculate area, it will come out as 2 square meter. For the station 100 meter, spot level is 1.4 meter, design level is 1 meter. So, area will come out as 4 square meter, which is in cutting. Again I am repeating, if the cross sectional area will come positive, that means it is in cutting. If it will come negative, it is in filling. Now, the third and the most important step will be calculation of volume of cutting and filling required. Volume can be calculated by this particular formula, V is equal to average cross sectional area into the length. So, for each interval we will calculate the volume. Now, the next and most important point is calculation of volume of cutting and filling required. Volume between consecutive stations are calculated using trapezoidal rule, which we have discussed in the calculation of area and volume also. So, volume calculation for each segment can be done as V is equal to average cross sectional area into distance between the stations. So, here for each interval we will calculate the volume. The first interval is between the station 0 meter and 10 meter. For each interval we will calculate the volume. First is between the station 0 meter and 10 meter. We can calculate average cross sectional area as minus 6 square meter minus 4 square meter whole divided by 2. It will come out as minus 5 square meter. So, volume will be area into length. So, area is minus 5 square meter, length is interval between two sections, which is 10 meter. So, it will come out as minus 50 cubic meter. Again I will repeat, this minus denotes filling quantity. Now, the next, between the station 10 meters and 20 meters. So, what will be the average cross sectional area? Average cross sectional area will be minus 4 square meter minus 1 square meter whole divided by 2. It will come out as minus 2.5 square meter. And volume we can calculate as minus 2.5 square meter into interval, which is 10 meter. So, the volume will come out as minus 25 cubic meter, minus means filling quantity. Now, we will calculate between the station 20 meter and 30 meter. So, average cross sectional area will be minus 1 square meter plus 1 square meter whole divided by 2. It will come out as 0 square meter. So, volume of earthwork will be 0 cubic meter. Now, between station 30 meter and 40 meter, average cross sectional area can be calculated as 2 square meter and the volume can be calculated as 20 cubic meter in cutting. It is positive means cutting. Now, between the station 40 meters and 50 meters, average cross sectional area can be calculated as 3 square meter plus 0 square meter whole divided by 2, which will come out as 1.5 square meter, and we can calculate volume by multiplying it by interval, which is 10 meter. So, it will come out as 15 cubic meter, it is positive, means it is in cutting. Now, between the station 50 meter and 60 meter, average cross sectional area is 0 minus 2 whole divided by 2, means minus 1 square meter. So, volume will come out as minus 1 square meter into 10 meter, means minus 10 cubic meter. Again, minus denotes filling quantity. Now, between the station 60 meter and 70 meter, average cross sectional area can be calculated as minus 2 square meter minus 3 square meter whole divided by 2. It will come out as minus 2.5 square meter. Volume can be calculated as minus 2.5 square meter into 10 meter, means minus 25 cubic meter. Minus denotes filling quantity. Now, between the stations 70 meters and 80 meters, average cross sectional area can be calculated as minus 3 square meter minus 1 square meter by 2. It will come out as minus 2 square meter. So, volume can be calculated as minus 2 square meter into 10 meter, means minus 20 cubic meter. Minus denotes filling quantity. Now, calculation of volume between station 80 meters and 90 meters. Average cross sectional area can be calculated as minus 1 plus 2 whole divided by 2. It will come out as plus 0.5 square meter. So, volume can be calculated as 0.5 square meter into 10 is equal to 5 cubic meter. It is positive, means cutting. Now, the last between the station 90 meter and 100 meter, average cross sectional area will come out to be 2 plus 4 by 2, means 3 square meter, and volume can be calculated as 30 cubic meter. It is positive, means cutting. So, we can calculate total filling volume as volume from station 0 to 10 as 50 cubic meter, volume from stations 10 to 20 as 25 cubic meter, volume from stations 50 to 60 as 10 cubic meter, volume from stations 60 to 70 as 25 cubic meter, volume from stations 70 to 80 as 20 cubic meter. Total filling volume will be summation of all this, means 50 plus 25 plus 10 plus 25 plus 20. So, it will come out as 130 cubic meter. Now, total cutting volume. So, volume from station 30 meter to 40 meter, it will come out as 20 cubic meter. Volume from station 40 meter to 50 meter as 15 cubic meter. Volume from station 80 meter to 90 meter as 5 cubic meter. Volume from station 90 meter to 100 meter as 30 cubic meter. So, total cutting volume will be 20 plus 15 plus 5 plus 30, means 70 cubic meter. So, what is the summary of this case study? So, for a road of size 100 meter by 10 meter with spot level taken at 10 meter interval, total volume of filling required is 130 cubic meter, total volume of cutting required is 70 cubic meter. I think this case study has given you some insight on application part of surveying. So, with this we conclude this session. Thank you all for your active participation today. We look forward to discussing the next topic in our upcoming class.